Okay, going over some limit strategies. We have a limit again. Now, we need to, first of all, look at the limit of x approaches 0. We're not going to be able to just plug things in because, again, we're going to left with something that's indeterminate because x is on the bottom. So if 0 is in for that, we're unable to solve for a limit. The other problem is simplifying the top of this. This is the third root of x plus 8. Becomes difficult to rationalize or simplify this expression. So instead of simplifying this, what we're going to do is we're going to set some variables equal to our difficult parts to answer, then simplify using those variables, then plug in our values at the end and find the limits. So what I mean by that is we're going to set up a let statement. We're going to say let x plus 8 to the power of 1 over 3, or the third root of x plus 8, equal, they've used the expression u. You could use anything you like, okay? And they use this expression here, u, okay? So what that means is we're going to replace our x plus 8 to the power of 1/3 with the value of just u, okay? Now, that's easy to do, but I still need to do something about the bottom of this equation here. We have the term x. Now that I've set up this let statement, okay, what we can do is we can solve for x. In fact, if I take u and I need to get rid of our, let's say, this fraction of a third, I'm going to multiply this entire, or I'm going to put this entire expression to the power of 3, okay? We're going to put this all to the power of 3. So when I put both sides of this expression to the power of 3, x plus 8 1/3 to the power of 3, and u to the power of 3, this 1/3 exponent and power of 3 exponent create a 1. And essentially not important because anything to the power of 1 is the base. So we'll get x plus 8 is equal to u cubed. Okay. Another important thing here, because then what that means is I can solve for x. X is equal to u cubed minus 8. So I now have set this up so that I can also plug in for x. Our x value will be u cubed minus 8. So that one let statement allowed me to replace two things that were going to be difficult to work with in this limit. Now that we've done that, we're going to plug those values in. So like we said, the limit of x as it had approached, what was the number? 0. We can replace our top with just u, subtract 2, divided by u cubed minus 8. And I'm going to bring your attention, we're going to zoom out because that might seem arbitrary. But what we did here is this part here was replaced with just u. So we have u subtract 2. And the x was actually equal to the value of u cubed minus 8. So we replaced the x at the bottom of the equation with u cubed minus 8. Okay. Now that I've done that, we really don't have any x's in here. We're going to see if we can simplify the equation with our variable u, then sub back in our x to see if we can actually solve this. Now, because we've set this to u, we're going to now move the x, or we're going to change the x to u as it approaches 0. So this limit now becomes the limit of u as it approaches 0. And if you guys remember, looking at the bottom, we have a difference of what? Cubes. You guys remember your difference of cubes and your sum of cubes rule? Okay, I'll quickly write it on the side here. If we have a difference of cubes, not squared, sorry, cubed, difference of cubes can be rewritten as a minus b multiplied by a squared plus ab plus b squared. Okay, that can be simplified that way, and vice versa with sum of cubes. Even though we don't need to know it, sum of cubes can be written as a plus b, a squared minus ab minus b squared. Okay? We're going to be using the red one because we had a difference of cubes. Now our a value in this is u, and our b value in this is, well, the cubed root of 8. Anyone know what the cubed root of 8 is? That's right. Cubed root of 8 is 2. So our b value is the number 2. So we're going to use that to plug in here. So, difference of cubed, a minus b. Well, a is u, b is 2, so u minus 2. And then u to the power of 2 plus a, which is our u again, multiplied by b, which is the number 2, so we're going to have 2u. And b squared, well, 2 squared is the number 4. So we've now made this a fraction that we can work with when going through it. Okay? So what we're going to do here is, if you look, we have u minus 2 on the top and bottom. We know that these will cancel each other out. So our limit of u as it approaches 0 is 1 over, and we have u squared plus 2u plus 4. Okay? So when we go to plug this in now, our limit of, oh sorry, not 0. I made a mistake. Our u limit shouldn't be at 0. Our u limit should be at the number 2. Okay? We'll go back over that in a sec. As our u approaches the number 2. Okay? And the reason we have that here is because that is essentially what's going to create our 0. Okay, I should have talked about that. I apologize. Our 0, if x had been 0 in this case, okay, when we're over here, if x was 0, we'd have 0 plus 8 to the cubed root of 8. Okay? Well, 0 plus 8 is 8, so the cubed root of the number 8 is 2. So our new limit for u is the limit of u as it approaches 2. I apologize. I changed it to u, but I forgot to change the number 3. So now that we have u as it approaches 2, we can plug it into this. Our limit then becomes 1 over 2 squared is 4. 2 times 2 is 4, plus 4 is 1 over 12. Okay. So, after we simplified this expression and we changed our limit, once we set it equal to u, we found a new limit, because when x was 0, that means the u would be approaching the number 2. So our limit as u approaches 2, we simplified the expression, because if we'd had the number 2 on top, we would have had a 0. We again wouldn't have found the proper limit. Okay? And we also had 0 on the bottom had it been the number 2. So we then used our difference of cubes to help simplify. When we simplified, we found the limit to be 1 over 12.